Hello everyone. So let's move to the next topic, that is Bitwise OR. Okay. So we are focusing on Bitwise OR, how this works. Let me write a simple question. So the question is um, 10 or 8, for example. So how to solve this question? So we're going to use the same method to calculate a binary. So I have this string, or I have this flow of numbers. So you just start with 1 and double the numbers. You will get these. So this is the pattern of bit slots. Generally, you have seen this in 32-bit architecture systems or 64-bit. Okay, so okay, so first we have to find the binary of 10. Check on what numbers we should add to get a 10. So that will be 8 and 2. Okay, so let me go to this and write below 1. Okay, then we go for 0. This will be 1. This will be 0. So this is the binary of 10. Okay, now we want the binary of 8. So it's very simple. You just have to check on what numbers we should add to get 8. Okay, so we put 1 here and all the numbers will be 0. All the previous numbers will always be 0. Okay, just like in mathematics. So this is the binary of uh, 10 and 8. Okay, 1 0 1 0 binary of 10, 1 triple 0 binary of um, binary of 8. Okay, so how to solve this? We are going to use a truth table. Okay, so how truth table work? So we have to create a truth table for OR 0 or 0. This will be 0. Okay, 0 or 1. This will be 1. Whenever you have 1 as an input, the output will be 1, or the charge will flow in the logic gate. Okay, so this will be 1, and if you write 1 or 1, the output will be 1 again. Okay, so whenever you find any 1 in the input, the output will always be 1 in the case of OR. Okay, so um, this is how it works. So if you calculate OR between these two values, so 0 and 0 will always be 0. So there is no charge. 1 and 0, 1 and 0 will always be 1. 0 and 0, this will be 0 again. And 1 and 1, this will be 1 again. Okay, so 1 0 1 0 is the output. So if you run this particular question or statement, this will return 10. Correct? So 1 0 1 0 is the binary of 10, obviously. So this is how you calculate, or you can try some more questions. So if I write then 17 or 16, or we can write 22, for example. So how to calculate these two numbers, how to solve this? What is the binary of 17? 16 plus 1 will be 17. Okay, so this will be 1 and this will be 1. So 1 triple 0 1 will be the binary of 1 triple 0 1. When you put 1 below this and 1 below this, it will give you 17. So what is the binary of 22? On what numbers we should add to get a 22? So 16 plus 4 plus 2. This will give you 22. So 1 here, this will be 0. 1 here, this will be 0 again. Sorry, we have to use 1 also. So 1 0 1 1 0, 1 0 1 1 0. So this is the binary of 22. So when you calculate OR for this, what will be the output? So 1 and 1, 1, 0 and 1, sorry, 1 or 1, 1, 1 or 0 or 1, 1, 0 or 1 again, 1, 0 or 0, 0, 1 or 1, 1. So 1 0 triple 1. When you write 1 0 triple 1, so triple 1 in the end, that means this should be 1. This should be 1 again. This should be 1. So 1 0 triple 1. This should be 0. And this should be 1. Okay. So let's add all the numbers that have 1. 16 plus 4, 20 plus 2, 22 plus 1, 23. Okay. So output will be 23. Correct. This is 20. This is the binary of 23. Correct. So this is how you solve or bitwise OR. Okay, that's it. Let's move on to next topic.